So 13.3 notes. It says, let theta be an angle in standard position, and let x comma y be the point where the terminal side of theta intersects the circle. So I want you to look at my diagram. I've got a point xy, and it's saying that xy is on the terminal side of the angle in standard position. Remember, standard position means it starts at the positive x-axis. Then we know x squared plus y squared equals r squared. If I drop that perpendicular, so that's an r right there. Then the 6 trig functions of theta would be sine theta is y over r, cosine theta is x over r, and tangent theta is y over x. And I'm going to, before we talk about a reference angle, we're going to define that in a little bit. Theta prime is when you drop a perpendicular, and if you're in the third quadrant, your perpendicular would come up, and in the fourth quadrant, it would come up. But if you do a perpendicular to the x-axis, theta prime is the reference angle. And so I can end up in this section, we can find the sine, cosine, tangent, and their reciprocals of any angle we want on the unit circle. So if you remember what we did yesterday, we played math ball, and by the end, you guys really had it where we just did pi over 6, pi over 4, pi over 3. And I think you guys really had a solid understanding of that. So let's look at example 1. It says, let negative 4 comma 3 be a point on the terminal side of an angle theta. So watch what we're going to do. We're going to go to the left 4, up 3, and we're going to plot that point. And what we're saying is this is the terminal side. It stops at the terminal side of angle theta. Okay? And what we want to do is we want to find the 6 trig functions of that theta. And even though I haven't described what a reference angle is, we're still going to use that. And we're going to use something called all students take calculus. Which is on my shirt. We're going to call the angle from the radius or the hypotenuse of the triangle to the x-axis. We're going to call that theta prime. And I went to the left 4. So even though the side of a triangle can't be negative, I'm going to label it negative so that this will work. And then I went up 3. So this is a common Pythagorean triple. The hypotenuse is 5. Now we're going to use the theta prime in place of theta, but I'm going to write theta because then I'm going to use the proper positive negatives that I need. From theta prime, sine is opposite over hypotenuse, so it's 3 over 5. Cosecant theta is the reciprocal. Cosine theta is adjacent over hypotenuse, so that's negative 4 over 5. Secant theta is the reciprocal. Now, initially that would be 5 over negative 4, but we put the negative in the numerator in a fraction. And then tangent theta is TOA, so it's 3 over negative 4, and we'll put the negative in the numerator. And then it's 4 over negative 3, and we'll just pop the negative in the numerator.
So we keep it as a negative 4 even though it's 4 units?
Yes. Okay, and the reason why, and we're going to talk about this tomorrow, all students take calculus, but I'm going to plant some seeds for tomorrow. What this means, all students take calculus, and you're right, I'm wearing my unit circle shirt, and it says, all students take calculus. And what that stands for is in the first quadrant, sine is positive, cosine is positive, and tangent is positive. Then their reciprocals go with them. In the second quadrant, because I went up, and if you remember to the first slide where it said sine theta is y over r, when y is positive, the sign is positive. So the S stands for sine is positive, but cosine would be negative and tangent is negative. And look at our answers. Isn't that true? Cosine was negative and tangent was negative. Now down here in the third quadrant, quadrant, the T stands for tangent is positive, sine is negative, and cosine is negative. What do you think the C stands for? Cosine is positive, sine is negative, and tangent is negative. So when we say all students take calculus, everything's positive in the first quadrant. In the second quadrant, sine and its reciprocal are positive, but the others are negative. In the third quadrant, tangent's positive with its reciprocal, and the rest are negative. In the fourth quadrant, cosine and its reciprocal are positive, sine, tangent are negative. All right, let's try it again with example 2. And you guys, when you're doing these, we don't need to have tremendous detail, because I don't want to figure out where negative 40 is. So go left a little and down a lot, okay? Well, you know, this we're just trying to figure out where this is. So let's draw, this is the angle. This is the angle theta. It's clearly in the third quadrant where the terminal side is. And I'm going to drop a perpendicular. And so I went left 9 and down 40. All right, now this is not a common Pythagorean triple, but it does work out nicely. I'm going to do negative 9 squared plus negative 40 squared equals c squared. 40 times 40 is 16 with 2 zeros. All right, I don't happen to know this one off the top of my head, but if you have your calculators with you, let's do the square root of 1681. 41. Now, we're going to use the angle that's formed from the x-axis to the terminal side. That's technically the reference angle. And then we're going to use the positive and negative signs. So here we go. I'm going to say it's the sine of theta, even though we're using the reference angle. So katoa, that's negative 40 over 41. Please keep consistent where we're putting reciprocals with the original function. So that's negative 41 over 40 for cosecant. Then I have cosine theta. That's SOHCA TOA, negative 9 over 41. Secant theta would be the reciprocal, but we put the negative in the numerator, so it's negative 41 over 9. Tangent theta, SOHCA TOA is opposite over adjacent. That's a negative over a negative, right? So that's positive 40 over 9. And then cotangent, I just flip that. And I want to pause here a moment and talk about all students take calculus again. All students take calculus. In the third quadrant, tangent should be positive. It is. And sine and cosine are negative. Do you see how that works? That's really pretty cool. All right, on the next page, what?
I was like, is this going to be drawing the units?
Well, I saved you a lot of time. I gave you the purple paper, and I want you to just take a moment and look at it. I couldn't print color for you, so I got you color paper. It was as best I could do. But what I want you to notice, I'm going to use my little circle. Here we go. Watch this. I do want you in this space to draw a circle here, but it's not going to be the complete unit circle. But here's the deal. If I draw an angle, and the reason why this is called a unit circle is that the radius is 1 unit. Okay, it's called a unit circle because the radius is 1 unit. And if I drop a perpendicular, if this is the point x comma y, that means I go to the right x and up y units. But the hypotenuse is 1 because it's a circle with 1 unit for the radius. Now watch this. The sine of theta is y over 1, or sine theta is y. This is going to be a critical piece of information. The cosine of theta is x over 1, or x is cosine theta. So what's interesting is that for any point x comma y on a unit circle, each value is cosine the angle, comma, sine the angle. So I want you guys to look at your purple papers, and let's pick an angle. Let's say pi over 6. Do you see on that purple paper it says sine, or cosine pi over 6, comma, sine pi over 6? Yeah. And then if you used your little triangles, your 30/60, that's radical 3 over 2, comma, 1/2. That's how you get all those values. Now let's pause a moment and think about all students take calculus. I want you to notice over here in the second quadrant, I'm 30 degrees away. Do you see that? And look, the ordered pairs are actually identical except the cosine's negative and the sine is positive. And if you look at the pi over 4s, they're the same, but cosine's negative in the second quadrant. This is my 30-degree reference angle, and cosine's negative. Now come down to the third and fourth quadrant. If I'm 30 degrees away, do you see these values are the same here? Here is the same as here. And they're all four the same, except in the third quadrant, tangent's positive, but sine and cosine are both negative. Okay? So they're both negative, and here, cosines are all positive, and the sines are negative. So it's really not like you're memorizing a ton of stuff. You really only have to do the first quadrant and then know whether they're positive or negative, then it just repeats. It's the same thing, okay? One other thing we need to talk about is tangent theta. If I look at tangent, that's y over x. But y is sine theta, and x is cosine theta. This is going to be huge, okay? This is going to be huge. So put a box and a star next to this. Tangent theta is also equal to sine theta over cosine theta. The other thing that's huge is that every ordered pair goes cosine theta, comma, sine theta. I don't know how you're going to keep that straight in your mind, except I think of C comes before S, so it's cosine theta, comma, sine theta. All right. We're actually going to skip example 3 for a moment. We're going to come back to it. Don't cross it out, okay? We're going to do it, but we're going to come back to it after example 4. Okay? So let's get to the formal definition for a reference angle. The reference angle for angle theta is called theta prime. So it's just the theta with a little tick mark that's a superscript. And it's formed from the terminal side of theta to the x-axis, and I've actually been using it with you without formally defining. So let's go ahead and draw an angle that's in the second quadrant. Here's theta. Then theta prime is from the terminal side to the x-axis, and it's always to the x-axis. So let's look at an example. Suppose my angle is 120 degrees. What would theta prime be? 60. How did you get that?
Because a straight line is 180 degrees.
So you did 180 minus 120, right? Or you take 180 minus the angle. If you're in radians, that would be pi minus theta, okay? Now let's go to the third quadrant. If I have a third quadrant angle, so this is theta, theta prime is from the terminal side to the x-axis. It's always to the x-axis. So let's say I give you that theta is 210 degrees. What's theta prime?
50.
How many? Not 50.
-30.
Reference angles are positive.
Okay.
How many degrees away? 'Cause it's a distance. It's like how far away am I from the x-axis? It's 30, correct? 180 to 210 is 30 degrees. But how do you find it? Theta prime is going to be your angle minus 180. Or theta minus pi. So look between the second and the third quadrant. Do you see how the 180 has switched? In the second quadrant, it's 180 minus your angle. But in the third quadrant, it's the angle minus 180 because it always has to be positive. Theta prime is always positive. All right, let's try the last one, which is the fourth quadrant. So if I'm going to draw an angle, that's a pretty blue, isn't it? Like, wow, that's a pretty color. So then this one, theta prime is always from the terminal side of the angle to the x-axis. So let's suppose I give you an angle of, let's say 310 degrees. What would theta prime be? How far away from that x-axis am I? 70, 50. How do you get that? You take 360 minus your angle. Or, if I'm in radians, that's 2 pi minus the angle. So stop, look, and think about these three. And I didn't do first quadrant because first quadrant, the reference angle is the angle, okay? So in the second quadrant, you're taking 180 minus your angle. In the third quadrant, you take your angle minus 180. And in the fourth quadrant, you do 360 minus the angle. You never, ever take this from the y-axis. You never subtract from 90 and you never subtract from a 270. Okay, that's not true. So let's look at some examples. It says find the reference angle theta prime, and in letter A, we're going to do this, theta's 5 pi over 3. And I need you to learn how to work with your radians. Like, theta prime needs to be in radians. But you do need to think about where is the angle. I need to know what quadrant I'm in. So what you need to do is you need to draw the angle to find the quadrant you're in. So 5 pi over 3, unless I can look at the unit circle, because the angles are on there, I do need to mentally be thinking about degrees. And let me give you a little trick here, a real helpful thing. If you look at 5 pi over 3, cover up the 5, and that's really pi over 3. How many degrees is pi over 3? 60. So I have 5 times 60, which is 300 degrees. So if you have a pi over 3, pi over 4, pi over 6, know that those are 30 degrees, 45, 60, and just multiply by that other number, okay? That's a fast way to do these. So if I'm at 300 degrees, that's fourth quadrant. So you need to draw the angle. So that's 300 degrees. This here is the reference angle, theta prime. Fourth quadrant, I actually don't memorize any of that stuff here. To me, it just makes sense to just figure it out. How far away am I from 360? I'm 60 degrees, right? Well, but I can't write 60 degrees because this was radians. And I know 60 degrees is pi over 3. So let me say that again. If you're given angles in radians and you're looking for a reference angle, it should be in radians. If it's degrees, you do degrees. Let's pop over to letter C, because that's in radians, and we'll keep in the same thinking. So remember what I just told you. Cover up the 7, and I have pi over 6. How many degrees is pi over 6? 30. 7 times 30 is 210. All right, what quadrant is that in, 210? It's in the 3rd quadrant, right? So how far away am I from the x-axis? Isn't that 30 degrees? 210 minus 180 is 30. That's pi over 6. All right, let's look at letter B now. I gave you negative angles. Let's look at negative 130. Negative 130 is going to rotate clockwise. And so here's a way to think of it. I'm at negative 130 and I'm trying to get, here's the reference angle is theta prime. How far away from the x-axis am I? I'm 50 degrees away. Reference angles are always positive. You can't have negative reference angles. All right, then let's look at letter D. I want to rotate negative 295 degrees. So when I'm doing the negative rotation, which is like the opposite of how we normally go, look at the board here with me. If I rotate negative 90, that's here. This is negative 180. There's negative 270, and I'm 25 more degrees into the 1st quadrant. Do you see that? So I'm starting here and rotating negative 295 degrees. My reference angle is how far away from 0 am I? Well, I rotated 25 degrees in. That's 65 more degrees. Okay? All right, now I want to go back to example 3. It says use the unit circle to evaluate the 6 trigonometric functions of, and we're going to do, we'll start with letter A. If I want the sine of 270 degrees, I want you to look at your unit circles. Look at the purple paper I gave you, and we need to find 270 degrees. 270 degrees is down here. And so the sine, remember every ordered pair goes cosine comma sine. So the y value is the sine of 270. So that's negative 1. And then please put your reciprocal functions right beside these. We're going to go down with all 6 because I don't have enough space. Cosecant is just the reciprocal. Well, negative 1 over negative 1 is still negative 1. Cosine, 270 degrees. I come back here to our point. The cosine is the x-coordinate, so it's 0. Secant, 270 degrees is 1 over 0. That's undefined. Please do not leave 1 over 0 as your answer. I'm going to mark it wrong. That's going to tell me you don't know what to do. Then tangent, 270 degrees. Remember what we wrote down in the box and we put a star. Tangent theta is sine over cosine. So it's negative 1 over 0. That's undefined. And cotangent, 270 degrees. Now I'm going to do the reciprocal. So it's 0 over negative 1, which is 0. So this one's okay. All right, let's look at letter B. I'm going to do this again with 180. So I have the sine of 180 degrees. I come over here to 180 degrees. Sine is the y value, so it's 0. So cosecant 180 is the reciprocal, which is undefined. Cosine 180. Cosine 180 is the x value, so it's negative 1. secant 180 is 1 over negative 1. That's negative 1. Tangent 180. So you know how I've told you that you already should have made 3 index cards. Here's another index card. Put tangent theta on the front and on the back sine theta over cosine theta. We're going to use that a ton. So tangent is going to be the sine value over the cosine value. That's 0. And then cotangent 180 would be negative 1 over 0, which is undefined. Any questions on how I'm coming up with these values? All right, let's do pi over 4 then. Sine pi over 4, if I look at my unit circle, I come up here to pi over 4, sine is radical 2 over 2. Cosecant is going to be the reciprocal. So that's 2 over radical 2. Well, I can't leave a radical in the denominator. So I rationalize, and I get 2 radical 2 over 2, which simplifies to radical 2. The nice thing is cosine pi over 4 is the same, isn't it? So let's not redo the work. Secant pi over 4 is just radical 2. Do you see how I did that? Then tangent pi over 4, that's sine over cosine. And do you notice I have the same number over itself? So that's 1. Radical 2 over 2 over radical 2 over 2, that's just 1. And I'm running out of space here. Cotangent pi over 4 is just 1, because it's the reciprocal. All right, last one. Theta is negative 150 degrees. Okay, I can still use the unit circle. If I start here and I rotate negative 150, isn't that this point right here at 210? Yeah. That sounds like my calculus video that we do. I'll have to ask her. But with this, yeah, it's the Bohemian.
But no, it's actually Bohemian Rhapsody.
Oh.
It's the same song we listened to, right?
Okay.
It's Mr. Wrinkle.
Oh, okay. Alright, so if I want to do the sine of negative 150, the sine is the y value, so it's negative 1/2. Do not drop your angles. When I collected first periods, I saw a lot of, and I said, don't do that, and they're doing it. As I'm seeing sine equals negative 1/2, I'm like, the sine of what? You can't have the sine of nothing. To be opposite, it has to be the opposite of the angle, so be careful. So that's negative 2. Cosine negative 150 would be negative radical 3 over 2. Secant negative 150 would be negative 2 over radical 3, and that rationalizes. Alright, now tangent's going to be tricky here. That's sine over cosine. So I have negative 1/2 over negative radical 3 over 2. Well, the negatives cancel.
Complex fractions.
Yes, and that's why we need complex fractions. So I'm going to multiply by the reciprocal, and I get 1 over radical 3. So that's radical 3 over 3. But when I go to do cotangent, you can use any step along the way, because these are all equal. So do you understand that cotangent is just going to be radical 3? Why flip and rationalize again when I had 1 over radical 3? Whoops. Ah! Hitting the wrong thing here.